Dear students, today we will discuss about a very important topic, that is grouping of cells. First come to series grouping. You see here it is grouping of cells a bit, that is series grouping. Here you have two cells. First cell has EMF E1, internal resistance R1. Second cell has EMF E2, internal resistance R2. You see here they are connected in series, that is end-to-end connection. Let I be the current coming from the combination, and you know, if I is the current coming from positive terminal of a cell, then the same current I is going to the negative terminal of this cell. So you see here the same I is going to the combination through C. So now you consider the first cell. For the first cell, what is the terminal potential difference? Let it be, this point is A, this point is B. So terminal potential difference is VAB. So VAB, that is VA minus VB. You know, for discharging of a cell, the terminal potential difference is EMF E minus IR. So it is E1 minus IR1. For the second cell, that is what is the potential difference or the terminal potential difference of the second cell, that is VB minus VC, that is E2 minus IR2. So now come to VSC, that is potential difference between A and C, that is VAB plus VBC, that is VA minus VB plus VB minus VC. So what is VA minus VB? That is E1 minus IR1 plus VB minus VC, that is E2 minus IR2. So it is E1 plus E2 minus, it is minus IR1 and here minus IR2. Minus I taking common, it is whole into R1 plus R2. It is your equation number 3. It is the terminal potential difference between A and C, or you can say it is the potential difference across the combination. So now you consider another cell which equivalent EMF GQ and internal resistance RQ. Just here I replace this combination by a cell whose EMF is EQ and internal resistance is REQ. This point you see it is A and this point you see it is C. From A, what is the current coming? I, and to this point C, what is the current going? That is I. Here, let EQ, that is the equivalent EMF of the combination, and REQ equivalent resistance of the combination. Now you can write VSC, that is potential difference between A and C. You apply the same formula. Here EMF is EQ minus IR2. It is your equation number 4. So you compare equation 3 and equation 4, you will get from equations 3 and 4, you will get E equivalent, that is E1 plus E2, and R equivalent, that is R1 plus R2. Here you have two cells, so you got EEQ, that is E1 plus E2, and REQ, that is R1 plus R2. If you have n number of cells, if they are connected in series like this, if you have n number of cells, then what is the equivalent EMF? EEQ is equal to E1 plus E2. It will continue up to En. Similarly, R equivalent, it is R1 plus R2. It will continue up to Rn. Here you see we have connected all the positive terminals of the cells towards left. You see here. If I will connect like this, it is E1 R1, E2 R2, and E3 R3. Here E4 R4. Then what is the equivalent EMF? It will be, you see, its positive terminal is towards left, that is E1. Similarly for E2, but you see for E3 it is negative terminal. So it is not plus E3, it will be minus E3, and it is again plus E4. Similarly, what is the equivalent internal resistance? That is REQ. You see, all the internal resistances are in series. So resistance here you cannot take negative. That is, so R equivalent will be R1 plus R2 plus R3 plus R4. So it is your series grouping of the cells. So now come to parallel grouping. BBIT, that is parallel grouping. You consider two cells. Here it is. It is first cell, EMF E1, internal resistance R1. Here EMF E2, internal resistance R2. I have connected the positive terminals of the two cells to the point A and negative terminals to the point B. So now tell me, for first cell, if from the first cell the current is coming, that is I1, and from second cell the current coming to the junction is I2. So what is the net current? That is I. I is equal to I1 plus I2. The same I current will be going to the junction B, and to the first cell the current I1 will go, and to the second cell the current I2 will go. So now for first cell, that is V, that is VA minus VB, you apply the relationship between terminal potential difference and EMF. You know it is the discharging of the cells, so it is E1 minus I1 R1. Or here we can write I1 R1 is equal to E1 minus V, or I1, that is E1 minus V divided by R1. It is your equation 1. For second cell, you see the points A and B, the potential difference across the second cell, that is VA minus VB, same as the first cell. So you can write V is equal to VA minus VB, that is E2 minus I2 R2, or I2 is equal to E2 minus V by R2. It is your equation number 2. Now, the net current I is equal to I1 plus I2, that equal to I1 is on this, that is E1 minus B by R1, and for I2 that is E2 minus B by R2. So this is equal to E1 by R1 plus E2 by R2 minus B whole into 1 by R1 plus 1 by R2. In LHS you have I, or V whole into 1 by R1 plus 1 by R2 is equal to E1 by R1 plus E2 by R2 minus I. So you can write here V R1 R2, and it is, you take LCM, that is R1 R2. Here it will be R2 and here it will be R1. So it will be R2 plus R1. So you can write R1 plus R2 is equal to, you take LCM here R1 R2, it will be E1 R2 plus E2 R1 minus I, or V is equal to E1 R2 plus E2 R1 divided by R1 plus R2, because this R1 R2, this R1 R2 can be cancelled, minus I R1 R2 by R1 plus R2. So now it is V is equal to E1 R2 plus E2 R1 divided by R1 plus R2 minus I whole into R1 R2 by R1 plus R2. You take it as equation number 3. So now you consider the equivalent EMF is EEQ and internal resistance is REQ. You replace the combination by a single cell of EMF EEQ and internal resistance REQ. This point you see it is A, and this point you see it is B. And from A, I is the current coming, and to the point B, I is the current going. So now you consider EQ is equivalent EMF of the combination, and REQ is equivalent internal resistance of the combination. Therefore, you can write V is equal to VA minus VB, that is V is equal to E equivalent minus I R equivalent. It is equation number 4. So now you compare equation 3 and equation 4. In place of EEQ, you have E1 R2 plus E2 R1 by R1 plus R2, and in place of REQ, you have R1 R2 divided by R1 plus R2. So from equations 3 and 4, E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. It is equation 5, and R equivalent, that is R1 R2 by R1 plus R2. It is an equation number 6. Now it is the equivalent EMF of the combination and it is the equivalent internal resistance of the combination. So in simpler form you can write EQ by REQ is equal to E1 by R1 plus E2 by R2, and this equation we have written for this, and similarly REQ can be written in this form. This equation can be written as 1 by REQ, that is 1 by R1 plus 1 by R2. When you will open this, you will get this. When you will open this, you will get this, because it is easier to remember. Because if there are two cells, then you can remember this. But if you have three cells connected in parallel, then you cannot remember in this way. So it is easier to remember in this format. That is, for three cells it is EQ by REQ is equal to E1 by R1 plus E2 by R2 plus E3 by R3. It is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here you see I have connected positive terminals to the point A. If one of the negative terminal, it will be negative terminal of E2 is connected to A point, to the positive terminal of the first cell, then it will be not positive, it will be negative, minus E2 R2. So all the things for internal resistance you cannot change the sign, only you will change the sign for EMF if the negative terminal is connected to the positive terminal of the cell. So it is all about your grouping of the cells. For n cells connected in parallel, you can write like this. And for internal resistance, it is 1 by R1 plus 1 by R2 up to 1 by R. So it is one of the important derivation type questions, that is combination of cells or the grouping of the cells, series grouping, that is a 2-mark question, and parallel grouping, that is 3-mark question. That is very, very important. You practice this. So in the next class we will discuss very, very important topic, that is Kirchhoff's laws.